Hi everyone, welcome back. My name is Micah and this channel is dedicated to learning, teaching, and discussing everything about cybersecurity. So today we are back in LetsDefend.io, and if you aren't familiar, LetsDefend is a blue team training platform designed to give users the ability to triage and investigate alerts based on real world scenarios. And this platform is perfect for those who are interested in the defensive side of cybersecurity and want to level up their skills. So with that out the way, let's get straight into it. So the alert for today that we are investigating is this data leak via Mailbox Forwarding Detected. And we can gather more context on what this alert really means by going to MITRE. And there is an entry under email collection, email forwarding rule. So I'm going to read this off a little bit. It says adversaries may abuse email forwarding rules to monitor the activities of a victim, steal information, and further gain intelligence on the victim or the victim's organization to use as part of further exploits or operations. So an attacker can gain or compromise credentials of a user and then create rules on the email client of that user to forward everything that's being received by that user to the attacker or some kind of third party for malicious reasons. And it goes on to say that furthermore, email forwarding rules can allow adversaries to maintain persistent access to victims' emails even after compromised credentials are reset by administrators. So let's say that the security administrator is aware of the compromise and they reset the password of that user, but the attacker still has access to the emails because there's no alerting or no type of alerting that's happening that's saying that, hey, these malicious email forwarding rules have been created. So that's just something to be aware of. So let's go back to LetsDefend. So I took the liberty of copying these details down and highlighting the more important details like the event time, the SMTP address of our local SMTP server. The reason I came to this conclusion is because this is a private IP address, our source address, destination address, email subject, and then the device action, which was blocked. So let's pivot to our mailbox and let's try to figure out what this email contained. So, okay, we see Catherine. It looks like some kind of data exfiltration. It seems like the attacker gained or compromised multiple systems and was able to gather these credentials from those systems and try to exfiltrate the credentials to this Catherine.isabel@yanix.ru address. But they were unsuccessful because it was blocked, as we saw earlier. So from here, let's pivot to the SMTP server to gather some additional information about this incident. So we're going to copy the SMTP address and let's go to endpoint security. We're going to paste in the IP address of the SMTP server, and it is an Exchange server hosted on the Windows Server 2012 machine. So let's go through these details. No browser history. We have some command history. It looks like some kind of reconnaissance going on. So this net user basically is an attempt to gather information about the users on the local machine, and more specifically the backup user from the user group on this local machine. And then someone added the backup user to the local group backup group. So I'm pretty sure there's a MITRE entry on this type of discovery tactic. Let's see, net user. So yeah, account discovery, adversaries may attempt to get a listing of accounts on the system or within an environment. So let's copy down this ID. We can just kind of add more context to our list. Let's just name this ILC, and we have ID T1087, and then we can copy down the time and the command history from our Exchange server. So we see, do we need all of this? Yeah, whatever. Let's just copy all this down. So this is all part of the discovery. And we can, what's this? Exchange server. And then the IP address is 172.16.20.3. All right, so we're just going to collect the ILCs from this incident for our incident responders so that they have some more information going into the remediation process. All right. And let's name this MITRE ID. Awesome. Okay, cool. So, all right, we found one IOC so far. Network connections, no network connections. Process list. So the only thing that sticks out are these two processes. So I'm not familiar with this hh.exe. So let's Google that. Let's close out that. Anytime that you see something that is malicious or suspicious, you definitely want to like do your due diligence and your research, figure out what it is. So this is from file.net. It says the genuine hh.exe file is in the software component of HTML held by Microsoft Corporation and is supposed to be ran in the C Windows directory. So let's double check and make sure that it's in the right directory. It is. So it's looking like it is not malicious, but we can go ahead and just double check. In VirusTotal, we have the MD5 hash. Okay, and it came back clean, so that's good. I feel like I have so much stuff open. All right, so the next thing, I think this is semantic. Okay, Notepad. It looks normal. We can go through all of these. It doesn't really seem suspicious. So this PowerShell.exe, this command clear event log system, is a definite red flag. It seems like the attacker was trying to cover their tracks. So I'm going to go ahead and copy this down and add this to our IOC list. And we can try to find another MITRE entry for this tactic. And let's just Google MITRE clear log. Indicator removal on host. So we have ID T1070.001. It says adversaries may clear Windows event logs to hide activities of an intrusion. So that's a huge red flag. And we're going to go ahead and copy this down as well, just to add more context to our notes here. We can run this through VirusTotal, but there's really no need to. We have the command right here. We see exactly what they're doing. So, yeah, cool. So from here, let's pivot to, or let's try to, well, we know that there has been an active intrusion on this Exchange server. So let's go ahead and request containment. And what I'm thinking what happened was the user, Catherine, she received, or she, I'm guessing it's a woman, but she received a phishing email. She probably clicked on it and then installed some malware, or was either redirected to like a phishing page, and that's where her credentials were compromised. So let's try to find that email. So we're going to pivot to our log management, and I'm going to close out some of this stuff because I have way too much stuff open. And we're going to pivot to log management, and then we're going to copy in the IP address of our Exchange server. We're going to see if there are any logs that pertain to the intrusion. Looking for Catherine. All right, so sender email, David at CashBank. We see the destination email, Catherine at LetsDefend.io. And urgent, your bank account may have fallen into the hands of fraudsters. So I'm guessing that this is the phishing email that we were looking for. And a lot of times attackers will try to invoke emotion to make users click on their phishing emails or links or whatever that's inside of it. So I'm pretty sure that this is the phishing email, and we can just double check by going to Exchange and what was the sender? David at CashBank. All right, so we see that this email from David at CashBank. It says, "Hi, I'm working at the CashBank fraud department, blah, blah, blah. And then can you quickly check your attached credit card statement and return it to us?" And it has this attachment, this zip file. Let's download this file, and we're going to save it. And then we're going to unzip it just to see what's inside of it. Hopefully you can see this. Let me make this bigger. So we're going to unzip this zip file that was sent to Catherine, and the password for these files on LetsDefend is infected. And we see that there's a credit card or a file called credit card inside of that zip folder or zip file. So let's try to figure out what kind of file this is. So we're going to do file credit card, and it says that this credit card file is an ELF 64-bit LSB shared object. So I'm pretty sure this is an executable file. We can double check by just doing some quick Googling. And let's see, Ubuntu executable versus shared objects. Let's try to find something that says it's executable. Or actually, let's just run it through file scan, and that should give us some additional context. Let's open File Manager. Let's just drag and drop this file onto file scan. We're going to consent to the privacy policy, give away our firstborn. We're going to hit upload, and then while that's happening, let's go to VirusTotal and do the same. So we're just going to drag and drop. And it gets flagged by 31 out of 59 security vendors. So I'm like 100% sure that this is malicious. We have plenty of security vendors that are echoing the same thing. And so it's ELF file, so kind of exploit CVE 2017-7308, CVE 2017-16995. So yeah, it's definitely not looking good for this sender and for that file. So I think we have the probable cause or the initial intrusion that created all of this. We can look through the indicator of compromise. We have some IP addresses. Interesting. Some domains. Are those domains? I guess so. We can try to cross-reference these IP addresses with what we found in our logs. So let's go back to log management, and let's copy down the sender. And we're going to also gather the other IOCs, like the IP address and then the time. So let's go back to XPath, and we have our IOC lists. And so let's say phishing email, and this is the initial attack vector or intrusion. Let's make that bold just to make it easier to read. And then we're going to copy down. We have the sender, and then we have the IP address of the sender, which is the 172.82.128.241. And let's copy down the timestamp. So it looks like this happened September 22nd, 2022. This happened sometime last year or 2 years ago. Wow, time flies. Let's put that first just to make it easier to read. And what was it? Credit card. I don't think it's an exe file, but we have, let's just say file. All right, awesome. So now we have a pretty good idea of how the attacker gained access to our network and some of the actions they took after the initial intrusion. But one thing we have not done yet is investigate Catherine's computer. So let's go to endpoint security and try to find her device. So let's type in Catherine. So Catherine PRD, this seems to be her device. So we know that she's installed malware. So let's go ahead and request containment. And we're going to go through the details of her device. We see some browser history. This seemed to happen before the intrusion or before that phishing email was received. So I'm not too worried about that stuff. And then we have something that happened way after the incident. So we can look into that. But for time's sake, I'm just going to keep going down this list. No command history. Network connections, the same thing. We see some of the repeat offenders here from our browser history, and then we have a process list. So this is where it gets interesting. We have this XFCE4 terminal, and we see that this terminal was used to run that malicious executable. So we have another indicator of compromise here. Let's go ahead and copy that to our notes. Let's go ahead and create another line here that says, I'm just going to put Cat's PC because I don't know how to spell her name, Cat's PC. Then we're going to paste the MD5 and all this other information that we just copied. And I'm going to move this to the top here just to make it easier to read. So now we have an additional ILC for Catherine's PC. And we also have the executable that was ran. It's probably a good idea to copy this stuff down as well. Oh yeah, and the start time and the username. So this was ran as root. This is very, very bad situations going on here, looks like. All right, so start time, let's move that to the top again for readability. That's a duplicate, so I can delete that. All right, so looks like this, like I said before, this executable is ran using this XFCE4 terminal. So the last thing that I would like to check is the event log for Catherine's device. So let's copy down the hostname and the IP address, and we can place that in our notes. It's probably better than just having Cat's PC here. And let's go ahead and check out the event log for Catherine's device. So let's go to log management. I'm going to paste that here. And we see that there was a GET request to that AMESIANA.com at destination address 23.227.38.71. And I know we have some URLs or some IP addresses from the executable that we checked earlier, but none of them seem to correlate with what was found in the logs. So, yeah. All right, so that's the last thing I wanted to check. So I think we have enough information to go ahead and close this alert out. So let's go ahead and do that. So, go to action, create case, hit continue, start the playbook. So parse email. Before starting the analysis, information about the incoming email should be obtained. I'm guessing that's referring to the phishing email that Catherine received. Let's hit next. Are there any attachments or URLs in the email? And yes, there was an attachment. It was a zip file containing an executable, and it was malicious. Check if mail delivered to user. Answer the following question by determining whether the email is delivered by looking at the device action part of the alert details. So I'm guessing that's referring, you said the alert details, and the action was blocked, so it was not delivered. So let's go ahead and enter our IOCs, and I'm going to go ahead and skip this part or fast forward just to save some time. All right, so I went ahead and entered the IOCs that we found. We have the email sender, a brief description, the email domain from the sender, the IP address of the SMT server from the sender. Then we have the two MD5 hashes. These are both the same. It wouldn't allow me to delete this one for whatever reason, but this is the MD5 hash of the executable that we found on Catherine's computer. So we can hit next. And then we can enter any additional comments. I'm just going to go ahead and copy and paste this entire thing down. If this was a real world scenario, I would, add some context, some additional comments, but nobody's going to be reading this. So I'm just going to paste that in there, hit next, hit finish playbook. And let's see how we did. Sorry about that. OBS crashed on me, but I went ahead and closed out the alert, and it looks like we got one of the playbook answers wrong. And so the playbook question was asking about the incoming email, and there was no incoming email inside of the alert. So I just assumed that they were referring to the phishing email. And I actually reached out to one of the owners on Discord, and he confirmed that there's an issue with this alert. So I'm going to chalk this up to the website being a little bit wonky, and I think that this was a successful investigation. So I'm happy with that. So yeah, that concludes the investigation. Hopefully you enjoyed watching this video as much as I did creating it. And please consider leaving a like, a comment, or even subscribing if you feel so inclined to do so. Doing so will help me out and will help this channel to grow. Right now, we need all the help that we can get. So please consider doing those 3 things. And thank you for watching. Stay safe, and I'll see you next time.